Right, so let's look at some of the notation that goes along with functions. So mathematicians use notation so that we can shortcut how we write things, so that we're not writing pages and pages and pages of things to just get an idea across. So let's look at kind of how this notation is going to work and what some of this notation actually means. So if we're indicating that a quantity y is a function of a quantity x, so in other words, if I sketch a little graph here, and I put x on my horizontal axis, so that's my independent variable. I put y on my vertical axis, so my dependent variable. I can write this as y is a function of x. Okay. Or y equals the words f of x. And in math, we write the words f of x as f with the x in parentheses. And then similarly, our output is a function of our input, or our dependent variable is a function of our independent variable. Okay, so these are all ways of getting at the same idea here. So let's look at an example of this. So for each of the following, we're going to identify the independent and dependent variables, and then we're going to express the situation using function notation. So our velocity v is a function of time t. So this time t is our independent variable. I'm going to put a t down for my independent, which means this velocity is my dependent variable. And the way that I'm going to express that using function notation is I'm going to write v is equal to f of t. All right, so I would like you to try this next one on your own. So go ahead and pause that video for a second and see how you do with that. All right, so my volume, big V, is a function of my height, h. So this height, h, is my independent variable, which makes my dependent variable this capital V. And so in function notation, this is going to look like capital V is equal to f of h. Okay, so that independent variable is going in here inside these parentheses.